Okay, so just for this assignment, we're going to do is just simplify, and then we'll actually do the identity stuff next week. But just for this, you're going to simplify. So simplifying would be if you can multiply stuff together, multiply together. If you can add things, add them. Get rid of fractions, get rid of parentheses, stuff like that. So here we've got multiplication. Let's see if we can actually multiply that together and make it simplified. So we look at this and we say cotangent x. Well, that's the same thing as what? 1 over tangent x. Okay, well, let's make this 1 over tangent x and multiply that with tangent x. What does that give me? 1. That's supposed to be a box. Simplify. How about cosine squared x plus sine squared x? We need to add those together. So right before lunch, we were doing Pythagorean identities. Is there anything, because Pythagorean identities are when you have them squared. Is there anything on that paper that you can add these together and see anything on that? See nothing? Not even the original question on that paper? That's equal to? Don't ask me how this is happening. I don't know how that just happened. 1. Should be a 1. Okay. Now we look at 1 minus cosine x and we look at 1 plus cosine x and we say, all right, I've got to get rid of like addition, I've got to get rid of subtraction, I've got to get rid of multiplication, and you start thinking about what you can possibly do. It's very possible that you might try something first and realize it doesn't get you anywhere and have to start over. It might happen. You're just going to have to accept that now. You might start something that makes a mistake. What I do not want is you not starting anything. I want you to look at this and say, I have no idea what to do, I quit, and skip it. What I want you to do is try something. So I look at 1 minus cosine x, and I might try to think what that equals, but do we have any identities that equal 1 minus cosine x? We do? Did you note? Never mind, because why? It's squared. The Pythagorean identities have cosine squared, not just cosine, and you can't just like square root stuff and make it what you want it. So these are not identities. You could change cosine into 1 over secant, but then you're making it less simplified because you're putting fractions in, and you're probably going to give yourself a headache. So something else we could try. Ideas? FOIL. FOIL this together? Okay. So we do 1 times 1, 1. Whoops, I'm still. Okay, I have no idea what's going on with this thing right now.
What's your going crazy today?
This one is. It was fine before lunch though. Sometimes if I come over here and use the computer for a second, it fixes it. All right, so we're going to have 1 times 1 is 1. Then we do outside, which is plus cosine x. Then we do inside, which is minus cosine x. Well, that was a big minus sign, sorry. Minus cosine x. And then we do minus cosine x times plus cosine x, so minus cosine squared x. Now what happens? Yeah, these cancel out and we get, didn't fix it. Let's try something else. Nope. Don't worry, I have a backup plan. guys won't mess up. Okay, so we get 1 minus cosine squared x. And is that a Pythagorean identity? What is that equal to? Sine squared x. So we have it simplified. Okay, the next one we've got, fractions and subtraction. Is there a way to not make these fractions? What's 1 over sine squared? Cosecant minus, what's 1 over tangent squared equal to? Cotangent squared x. And is that an identity by any chance? What is it? Oh, it's 1. How nice. That came from our Pythagorean identities. All right, next one is cotangent x times sine x. I'm going to say, well, cotangent x is the same thing as cosine x over sine x. Multiply that by sine x, which is over 1. I get cosine x. Next example, 1 minus cosine squared x over sine x. Any ideas? I see this 1 in this cosine squared x, and I feel like I saw that before lunch. Question? That is a Pythagorean identity, and it equals sine squared x over sine x. So then what do? Cancel out the squared with one of those, and we get sine x. Next one is secant squared x multiplied by 1 minus sine squared x. There are different ways of doing this. There are different ways. Does everybody have anything that, any of the stuff is equal to? Rachel?
1 minus sine squared x equals cosine.
Okay, so then I have secant squared x times cosine squared x. Any other ideas? Because I still have the times I need to get rid of, if I can. Ready? Okay, so I'm going to make that 1 over cosine squared x, multiply by cosine squared x. Cancel, we get 1. Next one, I'm just going to put everything into sine and cosine. So I'm going to take everything I see here and make it into either sine or cosine. So cotangent is cosine x over sine x. Secant is 1 over cosine x. And sine is just sine over 1. And when I do that, I can see, the cosines cancel, the sines cancel, I get 1. So some of this is really just kind of like knowing what they equal, and then some of it's being able to kind of think ahead what you need to do to simplify. This one here, I don't know if anybody's come up with the best way of doing this one on your own, so I'm just going to tell you what it is for this one. I'm going to look at this, and I'm going to see there's 2 separate terms, and both terms have a common factor. You see how both terms have sine squared x in it? So if I have a common factor, I'm going to factor that out. I'm going to write sine squared x multiplied by 1 minus cosine, or cosecant squared x. So I use my distributive property to multiply it, factor that out. And what, do we have 1 minus cosecant squared x is one of those Pythagorean identities? Do we have that? What? Is it one of them? Or no? What are you saying, Seth? Is one of them? Oh, okay. Tell me what that identity is.
squared.
Cosecant?
Yeah, minus 1.
Okay, so this is 1 minus cosecant squared. Here it's cosecant squared x minus 1. Is there a way to make this into a positive and make that into a negative? Multiply by -1? Okay, so if I multiply this by -1, do I only have to multiply one side of an equal sign by -1? So both sides. So if I multiply both sides by -1, then I get negative cotangent squared x equals, now I have a positive 1 and a minus cosecant squared x. And isn't that what I want to replace? So I'm going to replace this with negative cotangent. Still need to multiply these together. It's got one less term over here now, so we're getting closer. Any ideas what I should do? Christian? Change it? So it's still negative, but now we have negative cosine squared x over sine squared x. Why would we want to change that? Oh, because the signs cancel. And we get negative cosine squared x as a simplified version. Yeah? So, you notice how we're incorporating past math stuff in the new thing? One last one. Last one. Sine squared x, tangent x, cosine x. I'm thinking let's change tangent into sine over cosine. That's kind of what I'm thinking here. So I change tangent into sine over cosine. That's going to give me sine squared x over cosine x plus cosine x. Can I cancel those cosines? Good answer. Why not? Not multiplication. Okay. So what should I do? I got to get rid of the addition. I need to add them. What do I need to do to add these? Common denominator. So I have to make cosine, which currently has a denominator of 1, to have a denominator of cosine x. That means I have to multiply the top and the bottom by the same thing so that I'm really multiplying by a value of 1. Doesn't change the value, just changes the appearance. So when I add those together, I get sine squared x plus cosine squared x all over the common denominator cosine x. Okay, so I now have just one fraction, but I still have addition. Can I add together sine squared x plus cosine squared x? Is that an identity? See how we keep on to flip to that page? That page is pretty important. Which identity is it? What's it equal? 1. Okay, so now I have 1 over cosine x. Still have a division to get rid of. What's 1 over cosine x equal to? Secant x. Done. Okay? So I'm going to give you an assignment that's not due till Monday. You can work on it after you're done with your test because your test is so easy that you fly through it because you're studying so hard on it right now. Can't.